This is forced choice testing, or better one, better two. Measuring the physical property of the body using patient subjective opinion has problems. Whenever we're, as an example in acuity, looking at an acuity chart, the patient might subjectively decide whether they can or cannot see something. So a subjective criteria would be, do you think you can or cannot see something? And in some situations, you'd definitely say this was a Z. And in other situations, you'd say, well, this might be a D, it might be a G, or it might be an O. But subjectively, then I start to think, am I confident in myself? Am I nervous that I might be wrong? Am I only going to answer when things are perfectly clear or perfectly blurry? How am I going to answer? Will the doctor judge me poorly? Ultimately, the patient is using a criteria to make a judgment that can or will introduce bias into the results. As a doctor, we do not care about the bias or criteria and must work around it to get the right answer. All we really care about as eye doctors is if it improves vision. Now here's an example where we have a -2 lens and a -2 1/4 lens. The -2 diopter lens clearly has clearer vision than the -2 1/4 lens. A forced choice test is one that requires the test taker to identify or recognize a previously presented stimulus by choosing between a finite number of alternatives. In refraction, that's 2, which is why it's a two-choice forced choice test. Some examples of why we do forced choice testing is it's useful when there's suboptimal effort is concerned, as in the effort of the patient. If it's also based upon the premise that even imperative individuals will not perform below chance, so chance is a guide to actually find outliers or people who are exaggerating their problems. So anytime a person performs below 50%, that raises the suspicion that the patient is either exaggerating, performing suboptimally, or malingering. And this allows us to detect for noncompliance. Other examples of forced choice testing in eye care are color vision. Can you see the object variable, which has a variable number of choices actually? Visual acuity, as we just discussed. Can you read letters? 10 letters, there's 10 choices. Stereo. Which circle is popping out? Which in this case would be 3-choice forced choice testing. Or even visual fields. Can you see the light, yes or no? Which again is a 2-choice system. So let's think about this as subjective refraction. We offer now 2 choices, one of one lens and one of another lens, which improves vision. And that's the forced choice part of this test. 2 choices, they're both forced. In this case, as we just discussed, the -2 diopter lens clearly improves vision and the 2 1/4 lens clearly doesn't, so the person's acuity should match that improvement. Subjective refraction works in concert with visual acuities. The patient subjectively chooses which lens is better, and visual acuity must confirm it improves vision. I can't stress this enough. If vision does not improve, or it gets worse, that lens is the wrong lens. Subjective refraction refers to the subjective choice of options 1 or 2, not to how the patient subjectively sees the letters. You do not care if the patient thinks the letters are blurry, if the option 1 is better than option 10, or if letter E's are better than letter Y's. That is not part of subjective refraction. You only care if the VA improves. Nothing else matters during this test. Now, we do consider the subjective perception during the prescribing step, but that's not what happens during subjective refraction. Prescribing is when we take into account the person's habitual prescriptions, where the chief complaints are, and the findings from other tests. The endpoint for subjective refraction can be of 3 criteria. Number 1, the patient goes back and forth between 2 options. As an example, in a sphere check, the person says a -150 is clear, then 175 is clear, then -150 is clear. They went back and forth between the same 2 choices. The endpoint is one of those 2 lenses. The next endpoint is when the lens choice no longer improves VAs. And this is the most common one that's performed. So as we add minus, it should continue to improve VAs. When VAs stop improving, that's our stop point. And the third way we can end the subjective refraction is when the patient says the choices are equal or the same. So let's look at a couple of examples of sphere checks doing this. We have a starting lens of a minus 275, which the patient sees 20/25 through, and we've added a plus 75 fog to get them to 20/50. On our first choice, better 1 or better 2, we give a minus 2 or a minus 2.25. Remember, we're at minus 2 because we gave a plus 75 fog. The new lens, the minus 2.25, improves VAs. We go from 20/50 to 20/40, so our option is number 2. The same thing happens with options 3 or 4, the only difference being we've now randomized the minus. Now the first choice is more minus and the second choice is less minus. So in the next option, we give better 3 or better 4. Minus 250 is the better option that the patient says, and the acuity improves to 20/30 now. And we go on and on like this, randomizing choices and showing increasing amount of minus to ensure that vision improves. Now, when we get to the very bottom there, we've now given an option of minus 3.25 or a minus 3. In the previous option, we're at 20/20. When we show a minus 3.25, which they claim is the better option, their VA is in 20/20. It has not improved. So we have no improvement of the VA, so our endpoint was the previous lens or the minus 3 diopter lens. Let's look at another option that's a little more complex. In this situation, we still have the same situation of a minus 275 with a plus 75 diopter fog. And we go through very similarly. We have the minus 2 to minus 2.25, and we see VAs improve for quite a while till the very last option. In this case, the second to last option, the patient saw 20/25 with a minus 275 diopter lens. We try another quarter diopter of minus or plus in either direction. We cannot improve the vision past 20/25. Our endpoint for the time being is minus 275, where visual acuity stopped improving. Now this would suggest that the person has some underlying astigmatism present that we need to correct or modify. And so we would go on to the astigmatism check rather than continuing pushing minus because we have no improvement in acuity. So what are some guidelines for forced choice testing? Number 1, randomize the choices. Make them choose. Number 1, randomize the choices. Number 2, make them choose. Number 3, control the exposure time of each choice. Number 4, verify the choices through VAs. Number 5, challenge the patient from time to time to ensure they are answering correctly. Number 6, work from larger jumps to smaller jumps when checking astigmatism. And number 7, consider increasing the step size with poor responders. Number 1, randomizing the choices. Do not always give the more minus choice as the second choice. Some patients will start to make a biased decision that the number 2 or number 1 is always correct, which is not the case, instead of paying attention to which is actually better. For that reason, you need to randomize the choices throughout, whether you're doing a sphere check, astigmatism axis, or astigmatism power. You should always randomize the choices to confuse the patient and force them to pay attention. Number 2, make them choose. It's called a forced choice, not if a patient feels like it choice. That's the part of forced choice that it is. They must choose between the two options or say that they're the same. Not responding is not an option. Also, previous choices you gave are no longer options. It's only the 2 choices now. If you went through better 1, better 2, and you add a little minus, better 3, better 4 is a new trial. 1 and 2 is not an option anymore for this patient. They cannot respond 1 or 2. They must respond to the new choices. Use a new set of numbers, though, to help signify to the patient that this is a new trial. So after you've done better 1, better 2, go up to better 3 or 4, better 5 or 6. Now, you shouldn't go up to high numbers like 10, 11. You can start back over at 1 or 2, but you should always move to a new set of numbers. That way the patient knows it is a new trial with an entirely different set of lenses. Number 3, control the exposure time of the stimulus. Both options need to be exposed to the patient for the same amount of time, approximately 2 to 3 seconds. Showing one choice longer than the other will bias in favor of that choice. Due to accommodation, neural adaptation, the patient just gets to look at it longer and decide whether they can see it better or not. So the critical component is giving equal exposure to both choices. Number 4, use VAs to verify the correct choice. If the preferred choice or lens is better, acuity must improve. Here we have 2 examples. We've given a -1 and a -150 lens. The patient improves visually with the -150, they see better, so the correct choice is the -150. In the choice below, though, we still have that next choice. We have a half diopter more minus in one option, but it doesn't improve acuity, and acuity remains exactly the same. That means the correct choice was the previous lower minus lens, the -2 diopter lens. When in doubt, always choose the most plus lens giving equal or best acuity. Number 5, challenge the patient from time to time. Give the patient a choice you know should blur them. Obviously, more pluses ideally, to ensure that they're responding properly. So if you give them a click of plus, they should say that choice is worse than the previous option. If they don't, and they say the more pluses are the better option, there are 2 clear potential problems. Number 1, you didn't fog properly to begin, so there's more hyperopia or over-minusing present. The second option is the patient isn't responding accurately. They're not paying attention, or they're having difficulty due to depth of focus, due to age, due to exposure times. Number 6, work from larger jumps to smaller jumps for astigmatism. Refining the axis takes time, so start at 15-degree steps and work your way down to 5 and 1-degree steps as you go. And the final thing is really for poor responders. Sometimes you need to increase your step size with poor responders. This is especially true with older patients due to depth of focus, cataracts, other issues going on, dryness. In those situations, consider going to larger steps. Normally we do 0.25 diopter steps. Instead, go to a half diopter or 75 diopter steps to test the patient, which they can respond to easier. The larger jump, the easier it is to respond. Thank you.